Okay, welcome to GCP Online Meetup number 23. I'm Jonathan Cham, your host, and we have my friend Marco. Marco, how are you doing today?
Very good. Nice to meet you guys.
Yeah, we are going to talk about deploying applications quickly on Google Cloud Platform. It's something that's I'm very passionate about it. It's near and dear to my heart. Yeah, Marco and I come from VMware. We know a lot about infrastructure and complex and just how difficult it is to set it up. I love VMware, but no one likes to set up infrastructure, isn't that right?
Absolutely.
Yeah, it's not fun. So we have Marco today telling us more about exactly how do we deploy applications quickly on Google Cloud Platform? How do we remove all of the things that we don't like doing? How do we get straight to the business value and quickly deploy it onto Google Cloud Platform?
And how we can make developers' life easier so that they can really forget about everything that is related to infrastructure.
Exactly.
And all the steps and components that are required to actually go into deployment phase.
Yeah. So if you're a developer out there and you like setting up infrastructure, I'd love to hear why. But the biggest one we're seeing is managed and just want everything done for us. So Marco, what are we talking about today? Let's do it.
We're going to talk about how to develop application quickly on GCP. And the line is usually when you are trying to deploy your applications, how long does it take for you? How many clicks, common scripts you need to run just to deploy a new test version that you have just developed? So that's the bottom line. And the question is, what if you can just commit your code, just doing your Git or GitHub component and everything in a matter of seconds? That's the bottom line.
Old way today. I mean, what are people having challenges with today?
So there are different ways. The first one is what you see here. So you have this huge tool ecosystem. You try to glue together all the components. And then whenever you deploy, you hope that all the components are really working together and they're going to run the complete pipeline. So that's the first option. The other option is that you do everything manually, which means that you run a lot of scripts and in order to make it happen magically. So those are the two versions. The one that we are going to talk today is this one. So it's on GCP, one single platforms, no integrations. The only thing that you need to do is just to leverage the capabilities that are already inside GCP.
That's great. It. I mean, how many times do the integration parts of your pipeline break? That's probably my biggest pain in the butt.
Yeah, I mean, so if you think about the number of components that are involved in designing a complete pipeline, it may happen that one of the integration, you're upgrading one component, that component the integration stops working because of the upgrade. So you have all of these different issues, and obviously you want to, if you can skip all of these problems, it's much easier for everyone.
Yeah.
So obviously you need to do a little bit of plumbing, but as we will see, it's super easy and it's already all inside the platform itself. So it all starts with the developer, which is our blue dude here. And the developers, what usually does is to write code and commit it. So Google has a Git version that is available, which is called Source Repositories. So you can use that component to actually commit your code. But Google also has a wonderful component which is called build triggers, and that automatically listens to change repositories. And it can automatically build, in our case, is going to be containers. But the product managers for build triggers raised the point that actually we can build way more contents than just containers. So there are some extensions to build triggers to actually do more than that. But let's stick with our containers example because containers are the most straightforward and most used way of developing.
And Google Cloud Platform all of these tools provided. Okay.
They are all inside the platform. Okay. So that's a good piece. So once build trigger has finished building the container gets pushed into container registry, which is our container registry. So where we store all the containers and containers versions. Once we have completed that, you can leverage Cloud Functions to actually pick up the containers and deploy it into an existing Kubernetes cluster in Container Engine. So everything is already in there. It's all codeless. except for a little bit of code that you have to write on Cloud Function to actually trigger and run the deployment. So it's completely codeless.
People deal with, I guess, the development, test, and production. Would you just repeat the same pipeline for each stage?
So basically, what you could do is just to use the Cloud Function to deploy into different environments. So you can have multiple Kubernetes clusters, one for, or potentially multiple namespaces in Kubernetes, one for dev, test, and prod, and then just use Cloud Function to repeat the same steps in the different environments.
Got it. So actually the first 3 steps in this pipeline could actually be the same thing. Maybe you set a flag that says dev, test, production,
Absolutely.
and then based on that, the Cloud Function will actually deploy it on the different clusters.
Exactly. And the idea is potentially you can also have Cloud Function to trigger a notification to a human person before you actually deploy into the production environment.
That's great.
So that, by the way, it's something that I was looking for to actually extend the demo by using PubSub. Manage the notifications, but I mean, I've never had time to do that. So
yeah, you're a busy guy.
Exactly. So that's a real problem. And obviously, the other important component is that Stackdriver can monitor all the components that are involved, and it's automatically inside the platform. So you don't have to configure Stackdriver to do anything fancy. It's already in there. So just last slide before we actually talk about the demo, because I would like to highlight some use cases where this approach is definitely suitable. There are some limitations that I would like to highlight as well. So is you want to have a completely serverless and clickless build to deploy pipeline. So you just commit your code and everything works magically. It's full infrastructure as code defined, meaning that everything that requires building the container, deploying it into Kubernetes, it's all software defined. There's absolutely no real component involved.
Right.
The main use case is, for example, if you want to run unit testing for frequently committed code. So you frequently commit something, you want immediately to test whether it is working or not. That's the sweet spot of these uses. You have out-of-the-box monitoring, which is always a nice to have because if something doesn't work, you can immediately pinpoint where the problem lies. The limitations, so only because from an artifact repository standpoint, we only have container registry that can host containers. If you want to build something different, you will have to use a different artifact repository. But actually, build triggers can actually code. So that's something that works nevertheless.
And you're going to do a demo of this later, right?
Of the build component, I'm not going to demo building different different things.
Yeah, I think people definitely, at least myself, want to see this whole process.
Okay. So right now it deploys on an existing GKE cluster, but actually you can use Cloud Function to provision one if you want. The reality is that provisioning the GKE cluster requires a little bit of time, so it would make the whole pipeline last a little bit longer. So probably you don't want to do that, but nevertheless, it can be done. That's not a problem. So the biggest limitation I can see here is that you have a very limited governance or ability process. So if you're working in a big enterprise where you need to have KPI tracking, you need to have analysis of success failures, which packages are creating the most failures, this kind of information, probably this is not the best solution for you. Probably want to extend with something that is that gives a better visibility, just like Jenkins or Spinnaker.
Right.
So these are just the limitations. So that said, we can just go directly into the demo, and these are the components involved. It seems a lot, but actually it's very, very, very easy.
So how many tools are involved in this?
So that to some extent, I could say for this specific demo, there's only one component that is involved, that is GCP.
Okay.
But jokes aside,
Quit being a salesman.
Yeah. But jokes aside, 4 different components involved. We just really need to configure, honestly, 3 of them, no more than that. So that's super easy. In a real environment, you would probably need to have your source repository tool, your build tool, your artifact repository tool, your deployment tool, and overall orchestrator. So probably we're talking about 6, 7 different tools that you're going to require. at least. So it's a very complex environment to set up if you want to do that outside of GCP. Okay.
It seems like a business opportunity to have just one tool do everything. Is there a reason why this doesn't exist? Maybe it's just too many things and
multiple components that need to address very different use cases. That's the main reasons why there are multiple tools. So for example, if you look at your source repository versus your artifact repository tool, in one case, you have to be able to compare what is written in the different versions of the code, in the source repository code. In the other case, you want to understand the versioning and how they deployment strategy rather than actually versions, because those are binary contents, so comparing them from a human readable standpoint doesn't make any sense.
And plus, I'm assuming everybody deploys applications differently and just provides much more flexibility.
Exactly. It requires a lot more flexibility.
Going to the demo now.
Yeah, let's go into the demo. So the demo is really straightforward. So this is just a very simple web page that you can see here. It's based on NGINX, and basically this is your index in NGINX, which is the standard initial message that you have here. So on my development console, I have my index that I can edit, and I can change just the start text here. So I can just say, okay. Instead of using the standard initial message for NGINX, I can write here something like, this is the Meetup for application deployment.
This is a plug for the
GCP
Cloud Shell Editor.
Yeah, this is the Cloud Shell Editor.
IDE, this is straight in the browser.
Yeah, this is straight in the browser. If you want to use a different IDE, so potentially you want to develop your source code on your laptop, we are exposing a standard Git interface, which basically means that you can do that on your laptop, on a specific desktop machine, on any cloud development IDE, whatever you want. That's absolutely the same. The only requirement is that they can Git. That's the only requirement. I have changed my page. I can just now commit it.
Some source code, right?
Yeah.
You're committing it to Git. This specifically isn't GitHub though. It's actually.
This is Git.
This is Git.
I mean, at the end of the day, GitHub is just a hosted and managed instance of Git, which is exactly the same thing that we do with Source Repository at the end of the day. So I just need to push the contents now. Okay, so now that I have pushed the contents, my build trigger, which is here, is already building the new version. So there are a bunch of failures here because, as it's always suggested in all environments, I just made some cosmetic changes to the demo just 2 hours before actually delivering it. Okay, so.
Okay, I see. So what you've done is you've changed some code, you committed it. You have a trigger in Source Repository that says if a code change has been.
I have a bit here that basically has just built this new container. So as you can see here, the history tells me that it's been built just now. Okay, as you can see from the start. So actually creates a new container into the container registry. Has been built just now. So this is the container that the trigger has just built. Okay. Now, the interesting piece, which is what makes the integration work, so I'm just going through it very quickly, is that all of the containers that you build are actually hosted on our cloud storage platform. So now I am on the refresh. So basically now I'm in cloud storage, and as you can see, I have a folder which is containers that gets automatically created by GCP, so there's no manual effort involved here.
So container registry is it essentially free, but the storage you pay for the cost in GCS?
Exactly.
Okay.
So basically, you just pay for the cost in GCS. And actually, we have everything in GCS. That is what you have there. It's the actual container.
Mm-hmm.
Now, one of the way you can trigger Cloud Functions is actually to have Cloud Functions to GCS bucket.
Mm-hmm.
So in my case, I have a Cloud Function, which is here, that, as you can see, has already run.
Mm-hmm.
So the deployment into Kubernetes has already happened. And basically, this Cloud Function is very easy. It just says, this is my target bucket. This is this repository here contains, the repository is called automation, contains the actual code that I need to run. Okay, and that's it, basically. Mm-hmm. So every time it changes or a new file is uploaded into the bucket, and run that specific code that is in the automation folder. That's it, super easy. And the final result is reload my page.
Oh, there you go.
We now have
it
one version. It worked, so it's super easy. So just to drill very quickly down into how it happened. Mm-hmm. Okay.
And one quick question: if GCS, if you're not, so I mean, obviously Cloud Functions, it looks like there was some integration with, right? Mm-hmm. It knows what projects you have and what storage you have. If you're not using GCS, maybe you're hosting your container somewhere else, to still work.
Cloud Trigger. So the reason why everything is deployed in GCS is because we're using Container Registry.
Of course.
So the native integration is between Container Registry and GCS.
Mm-hmm.
But actually, if you use Build Trigger to build in a different way, mm-hmm. okay, you can have it target any artifact repository tool.
Okay. So like if you're using Docker Registry or something.
Exactly.
Okay.
Potentially. Yeah. So let's get into a little bit of the details. So in my Source repository, so in my Git installation, I have two actual repository. One is for the automation component. So in here, I'm going to commit and push the script that actually runs the deployment into GKE. Okay, which means that even the actual component that runs the infrastructure deployment is completely software defined. Mm-hmm. It is sourced and basically version in a source repository. And then I have another repository, which is my HTTP index, which actually includes the Docker file that instructs Build Trigger on how to actually run the deployment. So as you can see here, I have my Docker file here, which actually is trigger, and then I have my contents, and that's it, super easy. Is that Build Trigger is configured. Let's wait for the refresh of the page. Okay, so it's configured to actually. So it's configured to listen to my branch, use the specific Docker file to actually build the container. Okay, which is the Docker file that I have provided in the build directory. And then it creates a name where you can have a naming convention. I use this. Okay. And actually, you can also check down here in the black box what is the actual code that is run every time that you try to build your Docker container. So if you want to test it manually or for whatever reason, mm-hmm. you can easily do that.
Yeah.
Okay. And so this is completely automatic. And this is what triggers the build history here. So that's what happens. Once you have done it, or in Container Registry. So this new container here is stored here into the Container Registry. So you have your container here very easily.
Yeah.
Okay. Which from a storage perspective is in Google Cloud Storage. And then you just need to function that actually reads to cloud storage and runs the deployment. The cloud function itself, as I said, is
X is your cloud function.
My cloud function is very, so this is a demo that I had to develop for a customer, and cloud function runs Node.js code, mm-hmm. and I had no experience with Node.js. So I had to, let's say, take a crash course of Node.js in something like 3 days. So the function itself, and I'm going to show it, is very, very easy. So I have just these two files here that was just to bring credential and configuration into an external file, so that I'm not going to open it, because show credentials in a public meetup is probably not a good idea. But nevertheless, so this is the cloud function.
Right. Okay.
It's loading,
Yeah.
I think. It's fairly easy. So
Wi-Fi. I know some of the listeners are seeing some audio glitches as well, but
okay.
yeah, we'll do our best. I mean, so obviously you're not a Node.js expert, but it took you, you know,
exactly.
a couple
Something
days
like 3 days to develop
Yeah.
the contents, and I'm not sure if they're ever going to show up. But basically, let's say I can tell you that it's 58 rows of code.
Oh wow, 58.
All included.
Okay.
So
what you're doing it take you like an hour.
Exactly. But actually, you can see it there.
Okay.
Exactly. So if you're a better developer than I am,
which almost everyone is.
Kind of, I think so. So it can take you easily, yes, something like 1 hour to make it work. It took me 3 days because I'm not that good. So.
Yeah.
No, but jokes aside, yeah, I mean, the code is not amazing, but actually the reality is that it starts reading. You just need to tell the cloud function what are you looking for. So exactly in the storage bucket, in the cloud storage bucket, which one is the file that you're looking for. Pick up the name of the container, and then you have just to HTTP API of Kubernetes to actually run the deployment.
Okay.
The YAML that actually describes and is underlying the deployment is, again, software defined. It's version here in this automation repository, so everything is completely software defined. Once you have just created this connection between the different products, you can just leave them there where they are and just work on a software component.
Yeah,
that's it.
And I think one thing that's impressive to me is like we didn't set up any infrastructure for this pipeline.
Absolutely not.
There was no setup for Jenkins. There was no, I mean,
no,
it was
absolutely.
just a bunch of API calls and a little bit of boom.
So there was no infrastructure, and at the end of the day, there were components. Because in a standard pipeline, you would have to set up your Jenkins for building. You would have to set up some other tools to actually run the orchestration of the deployment phase.
Right.
In this case, there are almost no software components. The only software component that is required is just to write this very small piece of Node.js code, and that's it.
That's great. That's good. I noticed that I think some of these components are still in beta, right?
Source Repositories should not be. Cloud Functions definitely
Cloud Functions is in beta. Okay.
Definitely is in beta. Yeah.
Yeah, I have a customer using lots of Cloud Functions, and they're very happy with it, and it's very powerful. I mean, I think that's kind of the next generation of PaaS is just completely serverless.
Exactly, it's completely serverless. Yeah. So this is at the end of the day, our Cloud Function is our serverless implementation, and definitely is going to make platform as a service even more abstracted than it is already is from the infrastructure and the middleware components.
And I think we're looking to support as well.
Yeah, that's my understanding as well.
Because I'm terrible at Node.js, so I hope they do.
So
so are you apparently. But
exactly. I didn't know Node.js just before having to do this stuff. So I started playing with it. It's pretty straightforward. I have to say that I was kind of knowledgeable of JavaScript, which helped me a lot.
Oh yeah.
Yeah, because of some
similarities.
Yeah, no, I mean the language itself is the same. It's just the logic that is slightly different. And I was knowledgeable of JavaScript because of some front end historical work that I had to do something like 15 years ago. So that's the reason. But yeah, it's pretty straightforward.
Okay, great. What's next?
Well, next is probably trying to target different environments so that we can really run a pipeline which is dev, test, and prod, and potentially integrate with PubSub to actually have notifications sent to other ways to the actual release manager so that they can make an informed decision on whether to deploy into production or not.
Got it. Yeah, no, thank you so much for the demo. That was really cool. I mean, you tied in 6 different components into this pipeline, and it works, and it was very easy. I mean,
it was very easy.
Like anybody can really set it up. You don't need experience. If you're writing code already, this is pretty much a no-brainer.
Exactly. So if you are already, so the biggest problem I had here was to actually write Node.js code. Else is very straightforward, and it's very well explained on our blogs. So it's really out of the box.
Question. So Giuliano asked if the source code will be available. You think you can make it available?
The Node.js one?
Yeah.
So as I told,
Well, take out the credentials maybe.
no, the credential is already
okay.
out, so I can just remove
Okay.
them. I can definitely make it available on Git. That's
Okay.
not a problem. Please don't blame me for the quality of the code.
Yeah.
I'm not a good programmer, so that's the only
Yes,
request.
yes.
Don't blame me
So
for that.
no, I guess no request for fixing bad code. Yeah.
Well, maybe I can, in my spare time, I can try to fix something if it's not working, but definitely don't blame me for the quality of the code.
Yeah, exactly.
I know it's not very good.
Yes, I mean, this is really good. I think a lot of people will benefit from this. I mean, any other things that customers should be aware of in terms of deploying quickly into GCP? I mean, you provided an entire pipeline, but this is what are some gotchas? I guess you discussed some earlier.
Yeah.
I mean, Node.js I think is kind of one of the big ones, and a lot of programmers maybe doing Python or Go aren't Node.js friendly.
That's definitely one of them, meaning that with this approach, you don't have to set up a listener listens to any change into cloud storage to actually trigger the deployment.
Mm-hmm.
But actually, if you want to develop it into another code, you can easily use App Engine and code the actual listener versus the GCS bucket on your own.
Mm-hmm.
So that's another approach that will allow you to use different programming languages if you don't want to use Node.js. Other gotchas. Is that the piece of code that I have developed actually listens to only one a GCS bucket, and it doesn't screen between potentially different containers that you want to. Let's say you have a Kubernetes pod that actually is made up of different containers.
Mm-hmm.
Okay, this one doesn't screen which containers we're talking about,
right?
And which one you want to deploy, but that can be easily worked around by creating multiple functions or that listen to different containers storage buckets,
mm-hmm.
or potentially having different triggers. So that's something that you can around.
Right.
And those are the gotchas I can think of. As I told, the biggest limitation I can see is the lack of visibility on specific KPIs, because in complex environments where you have release managers, those release managers are really looking at those deployment KPIs. So how long did it take? Which one are the 50 packages? So these kind of KPIs, there's almost no visibility about that. You can kind of collect the data out of Stackdriver if you want, but you would still need to develop a portal that actually shows those data in a meaningful way.
Mm-hmm, mm-hmm.
So that's the biggest limitation I can think of.
Yeah, I think one thing that we didn't really cover in the whole Stackdriver integration, it's pretty nice to have everything tracked for you in Stackdriver. But again, another limitation of this whole serverless and completely managed is some people want a lot more control. They want to see what's going on underneath, and maybe for troubleshooting purposes, they really want control over the infrastructure running. Yeah,
nevertheless, Stackdriver definitely gives you a complete visibility. So in the Node.js component, if there's an error, you just trigger a system output, and that output will be written into Stackdriver. So if you want to understand what's not working, you can easily get it out of Stackdriver of the code. So that's super easy as well.
Question. I'm going to put you on the spot here, Marco. I mean, I'm hearing a lot about Spinnaker, right? It's becoming kind of very popular. It stemmed from, I think, a Netflix and Google partnership to build a, I guess, cloud agnostic deployment tool.
Yeah.
How does this fit into that?
You could definitely use Spinnaker as a replacement of the cloud function component that is in here. So that's where it would fit nicely. The only, obviously, the advantage of using Cloud Function is that you do not need to configure anything. So the deployment is super easy. But Spinnaker allows you to have, so in this example,
white, red, black, and blue.
Exactly. I was getting exactly there. So in this example, you just change the pod that you have deployed with a new version. So that's suitable for unit testing, basically. With Spinnaker, you can define canary deployment, black and blue environments. Green and blue environments. Black and red is the strict one. And so you can you can define all of these policies that clearly would be extremely tough to be described here in the Node.js code.
Right. You can do it probably.
You can do it,
you know, because Kubernetes supports that, right?
Exactly.
I mean, but it's just a lot more coding. Provide that more out of the box.
Exactly.
Yeah.
That would be out of the box with Spinnaker. And again, the biggest advantage of Spinnaker is that whenever you start your, for example, your canary grade, have visibility of which pods are working or not, and potentially trigger a rollback if you figure out that something is not working properly.
Yeah.
So that's where you have clearly definitely some advantages by using Spinnaker.
Got it. Well, good. That was great. I mean, I'm super excited. I don't see any other questions, but you know, thank you so much, Marco, for this pipeline. And tune in this Friday. We actually have another online meetup where we're going back to back this week. We're going to talk about deploy. Yeah, that's pretty fun. Yes, it's similar, right? You kind of automating the whole process of deployments, except that's more maybe infrastructure focused, where you need to deploy some infrastructure and comes in. But no, thank you so much, everyone, for tuning in. This is great, and we look forward to having you next time.
Thank you.
Thank you.